Good morning, everybody. This is Stan Forrester. I'm your instructor, and I just received a request for assistance through the Ask My Instructor. Remember that we'll go ahead and move this a little bit. Well, it doesn't actually show it. In your view, there'll be a little button down here that says Ask My Instructor, and that'll send me an email. And of course, that remains anonymous, so nobody needs to be embarrassed about asking for help. And this one is actually a problem that most people need a little bit of help with. Okay, so here's the question. If possible, find, if possible, the number of elements in sets A, B, and C using the information on the right. And the main thing we're looking at here is the symbolism. N of A simply means we're looking for the number of elements in that set. Now, the information we're given is we're given the number of elements in some, well, oddly defined, well, not oddly defined, just unfamiliar terminology defined sets. So let's see, we have A intersection, this upside down U symbol here is intersection, A intersection B. And so what we're looking at is for a set A and a set B, we're looking for those elements that are contained in both A and B. Now, I've gone ahead and I've drawn all three sets here and labeled each of the regions. So R1 is a region that's outside of all of the sets. Any elements out here are simply not going to be counted. Okay, region 2 is the set of everything that's just in A and in no other set. R3 and R6, though these are the intersection of A and B, and whoa, look at that. The intersection of A and B is 10. So we can say that R3 plus R6 is equal to 10. All right, and I've got that written down here, and I've used the little letter N for intersection and a capital letter U for union, so we'll use that later. So the number of elements in the intersection of A and B is simply going to be R3 plus R6, and we know that that's 10. Well, let's see, do we have any other clues out here? Let's look at this one here. We have the number of elements in the intersection of A, B, and C. Well, which region is the intersection of A, B, and C? And that's just R6 here. So that's just one region. We know that then that R6 contains 4 elements. And let me see if I can draw this. Remember, I'm doing this with a mouse here. So R6 contains 4 elements, but we already know that R3 plus R6 equals 10. And so R3 is going to have 6 elements in it. Well, let's look around and we'll see if we have any more of these two set intersections. Here's the number of elements in B, number of elements in the set B intersection C. So there's B intersection C. We can see that's 9 elements. Well, R6 and R7, which is the intersection of B and C, has 9 elements. We know that R6 has 4, and so R7 is going to have 5 elements. Let's see if I can draw that out there. All right, R7 is going to have 5 elements. Let's see if we have an intersection of A and C. Do we have an intersection of A and C? Indeed we do. The intersection of A and C, let's look at that. The intersection of A and C is R5 plus R6. And so we know that that's the sum of these two is 8. R5 plus R6 is 8. And we have another 4 here. All right. Now, we need to address R2, 4, and 8. Let's see now. If I take this element, this statement here, the union of all of these sets, in other words, the number of elements it's going to be, this is all of the elements that are contained in R2, 3, 4, 5, 6, 7, and 8, right down here. We know that that's going to be 28 elements. But now let's take a look at the union of B and C. The union of B and C, that's going to be 25 elements. Well, that's simply going to be R3, 4, 5, 6, 7, and 8. It's going to be all of the ones in the previous statement down here except R2. So all of these contain 25 elements, and if we add in R2, it's now 28. So R2 has 3 elements in it. What about set B? Well, here's an interesting one. This is the number of elements in the set B minus A. B minus A. Well, here's the set B. Here's the set A. So B minus A is going to be all the elements in B minus those that are also in A. And so that's going to be 7 elements, but we already know that the set defined by this is going to be contained in R4 and R7. We know that this one is already 5, so that R7 plus R4 is equal to 7. So we know that R4 is going to contain 2 units. Well, now look at that. If we take a look again down here, we see that the number of elements in all of these together is 28. And I'm going to go ahead and I'm going to leave that last one for you. Remember, we have numbers for all of these here. You can figure out what the value R8 is if once you know that the sum of all of these has to be 28. Now, let's go ahead and figure it out. The number of elements in A. The number of elements in A. So this would be 6. Well, remember, the elements in A is R2 plus R3 plus R6 plus R5. So let's figure this out. 6 plus 4 is 10. And then we have 17. So let's go ahead and let's type 17. Well, I will type 17 in there in just a minute. 1, 7, bring that back. How about the number of elements in B? The number of elements in B. So we have 6 plus 4 is 10 again. 15, 16, 17. All right, 17. All right, let's bring this back. And I went ahead and I figured it out. I know what the value is in R8, and I happen to know that when we add all these together, we're going to get 17 one more time. And the answer is certainly it is possible to find the numbers. So it's not answer B, but we have answer A here, and we have these 3 17s. And I'm going to just move this up a little bit so we can check the answer. Yay! See, we did really good. Okay, so that's a little bit about set theory, working with sets in Venn diagrams. Please keep the questions coming, and I'll catch you on the next tutorial video.